Hi guys, today we are going to be going over electric fields and electric field lines. We're going to be going over what exactly those are, how to solve for electric fields, and how to draw an electric field line. So first, let's talk about what exactly is an electric field. An electric field is an interaction between two objects without any physical connection. Electric fields are caused by electric charges. So to visualize this, let's watch a short clip. The big metal thing in the center is a charged sphere, and that is a piece of string attached to the ruler, and you can see that the string is not coming even close to the charged sphere and kind of keeping away from it at the same time. So as you can see, there's no contact between the string and the charged sphere. However, there definitely still is interaction, and this is what an electric field is. So now let's go over how to calculate an electric field. The equation to calculate an electric field is E equals F over Q. E is going to represent the electric field, F is going to represent the electric force, and Q is the test charge. Now Q is always going to be a positive test charge placed in the electric field. So basically this equation is taking the variables of an electric field and the force and seeing how it interacts with the positive test charge, and from that you can figure out different variables, in this instance the electric field. So now we ask the question, what do electric fields look like? As we saw in the video earlier, we couldn't really see any physical connection between the charged sphere and the string. So how are we going to illustrate these when we draw them in diagrams? So there are a couple of basic rules that we want to follow. Number one is that an electric field extends from an object in all directions. So basically that means that an electric field is not only going to come out from the top of an object or from the side of a particle or whatever, it's going to come from all different angles. To represent these electric fields, we draw diagrams like the ones below. The lines are considered the electric field lines. And we'll go more in depth about the arrows and the closeness of the arrows and what that represents in the next slide. So now let's get on to some basic steps for drawing electric fields. Number one, field lines must begin on positive charges and end on negative charges. The ones you see in the picture below are actually hypothetical isolated charges and go on for infinity and therefore have no beginning or end. But just know that in the real world, field lines begin on positive and end on negative charges. The closer the lines, the stronger the field. Number three, the number of field lines is proportional to the magnitude of the electric field. Number four, arrows point in means that there's a negative charge. If the arrows point out, it means there's a positive charge. Number five, direction of magnetic field is tangent to the field line at any point. And number six, field lines can never cross. So let's take a look at these rules in comparison to the pictures below. The picture letter A has arrows pointing out from the charge, which means that the charge is positive. B has the arrows pointing in towards the charge, therefore the charge is negative. And then finally on C, you can see that there are a lot more lines coming into the charge, or the center, and that means that the magnitude is greater and the field is stronger. So you can compare that B and C, they're both negative, but C is going to be a much larger charge. So now you might ask, well, what happens if I bring in a positive and a negative charge and put them close to each other, or a positive and a positive, or a negative and a negative? Well, there's some rules with that too. You probably already know that opposites are going to attract, and the same charges are going to repel each other. So you can see that the same charges on the top picture are going to repel each other. This one happens to be two negative charges, but is the exact same for two positive charges. And those two charges are also of the same magnitude. So they're equal charges, both negative, and they repel. And you can see on picture B two charges that are of the same magnitude, but one's positive and one negative, and you can see that they attract. And one big picture thing here that I want you guys to get is that electric field lines cannot cross. So let's go over what we just learned. An electric field is going to be an interaction between two objects without physical contact, and it's caused by charges. It's mathematically calculated by the electric field equals force of the field over Q, the positive test charge. And field lines represent the strength and charge of electric field. More lines means there's greater strength. If the arrows are pointing in, it's a negative charge, pointing out positive charge, and field lines cannot cross. I hope this really helps.